Hi, hello. Welcome to my channel, AI Round the Clock. I hope you are all doing good. Today's video is about Edge Data Center and AI. The video covers basic concepts of Edge Data Center. What is an edge, why we need an edge, and how to connect with edge. Then we will look into design concepts of edge use cases, and finally, when to go for a traditional data center and when to go for a edge data center for artificial intelligence applications. To begin with, let's take an example of a shopping mall and then connect with edge data center concepts. Case 1. A large shopping mall is a large building, say 5 floors, with 500 plus stores with both local and global products, gaming zone, food courts, a parking lot. This large shopping mall is located outside your city or town. Now, case 2. A small shopping mall is a small building with 2 floors, 20 stores with local products, and a few food courts. This shopping mall may or may not have a gaming zone and have limited parking space. Case 2 shopping mall has a fewer amenities than Case 1 large shopping mall. In Case 1, as shopping mall is large, the building needs tight security, more electricity, and more coolers than a small shopping mall. The footfall in shopping malls in both Case 1 and Case 2 depends on the customer needs. In Case 1, the core data center is like a large shopping mall. Core data center in your state or in a broad geographic region like AWS, GCP, handling billions of user requests and response in a day. The case 2, Edge data center, is like a small shopping mall in your locality, near to your house, or within your city, processing data locally, say millions of user requests and response in a day. Edge data center refers to running a computer server closer to the client data source so that server can respond more quickly to the request from the client. Edge data centers are smaller, decentralized facilities that can process data closer to the users. Edge data centers can be totally and independent self-sufficient local data centers, or edge data center can be a small replica of core data center. If there are complex tasks like running a large language model which needs powerful computational resources, then edge data center offloads the intensive processing from the edge and executes this intensive processing on the core data center. However, these methods of edge replica need robust network connectivity to transmit data between the edge and the cloud, which may introduce delays and privacy concerns. Having an independent edge data center reduces the delays in request and response by avoiding round trips to the servers. If your mobile phone has a high processing power, then your phone itself can act as an edge device. Now let us see why we need an edge data center. There is huge data traffic between the server and the client. There are various loops between the points on the network. These loops slow down request and response between the client and the server. Client can be an app on mobile phone. Edge cuts down the latency by placing server closer to the client and thereby enhances user privacy as the user's personal data stays local. Edge also minimizes bandwidth usage. Now, how can a user access Edge data center? User can access Edge data center through internet connection, or through virtual private network or wide area network. Now moving on, let's see the challenges involved in designing an edge data center. Selecting and securing an edge data center are two important factors to be considered while designing an edge data center. First, determining the location is critical to the success of edge data center. Second, a workload need to have a reason to be at the edge. A workload could be a video streaming application or an IoT application, or it could be a large language model, a small model, or a tiny model. If workload doesn't have a significance to be at the edge, then it would be more convenient and economical to host the workload at an existing core data center. Third, rack density or size of data center. Computer hardware used in data center is called rack, and rack is measured in U's. A U is 1.75 inches of vertical data rack. Let's say if a server is listed as 4U, means 4 rack units, that is 4 multiplied by 1.75, which is 7 inches. Remember shopping mall example from previous introduction slides? Large shopping mall needs more electricity, more cooling, and more security than small shopping mall. The fourth point in selecting the edge data center is about these basic amenities in the locality. Is there enough physical space to set up an edge data center in the locality? Is there enough electricity, cooling system, enough security, backup system in case of power outage? Now, last but not least, the most important factor in selecting the edge data center is data sovereignty regulations, where government places strict constraints on storage and movement of citizens' data within the country and outside the country, like GDPR, General Data Protection Regulations by EU, DPDP, Digital Personal Data Protection Act in India, and California Privacy Act CCPA. After selecting the edge data center based on location, workload, basic amenities, government regulations, the next important design consideration for edge is, yes, you are right, it's securing the data at the edge. The threats could be human threats like misuse of storage devices, cyber attacks, natural disasters like earthquakes, power outage, wildfires, snowfalls, and many more. The threats can be mitigated by installing cameras and touch sensors in building and on hardware to detect if the hardware has been stolen. Then have frequent backups of the data, have a good encrypted algorithm at the edge, and a good incident response workflows to handle and fix threats in real time. Now, moving on to the use cases of edge computing, critical infrastructure such as transport system, hospitals are prioritized for edge data centers. IoT sensors and smart homes like thermostat, security cameras, lights, washing machines generate great amount of data. Edge can process this data locally and adjust temperature and light settings as per user preference. Small smart cities with intelligent traffic control system that time traffic lights red, yellow and green for 30 seconds or 60 seconds based on traffic flow can minimize traffic congestion in real time. In autonomous vehicles, edge-based language models can interpret and respond to passengers' voice commands to control navigation in real time. Interactive real-time experiences such as gaming applications, financial services, healthcare, where multiple parties interact in real time is a good use case of edge computing. Financial services. Buying and selling stocks involves executing transactions on multiple connected computer servers. Even a fraction of a second delay in execution can make a large difference in the profitability of the stock market. In such cases, it is preferable to store and process the data at the edge for real-time updates. And the next important use case of edge is healthcare. Edge-based language models enable real-time natural language interactions between patients and medical devices. Models on edge devices can assist healthcare professionals by providing instant access to medical tools, patients' records. This can improve patient care, especially in remote areas and in resource limited situations. Now let us see the choice between core data center and an edge data center with a use case. Surveillance system. A camera on your cell phone or a security camera on your home network transmit the data to remote servers. Then these servers process the data using machine learning models for face detection or for a behavioral understanding like loitering, tailgating, and unusual activities. In above case, if the camera installation and data processing is on large scale, that is data from multiple cameras must be aggregated for a broader pattern recognition, then remote cloud data can be used. In the above case, if the pattern recognition is limited to a particular locality, that is data from a single or data from a few cameras in the locality are considered for processing, then edge data center can be deployed. Edge servers reduces the gap between the data generation and data processing through direct execution of algorithms on edge servers. This helps in real-time data analysis and decision making. This proactive approach to security ensures swift action. The choice between a global or local execution, that is, execution of AI models at the traditional or core data center or at the edge data center, depends on the specific requirements and constraints of use case. I hope this video covered basic understanding of edge data center. I'm working on advanced concepts of edge. I'll post the video with advanced concepts soon. See you in next video. Until then, please like, share and subscribe to my channel. Thank you for watching.